Right now, as you listen to this, you are lying in darkness. Your room holds warmth. Something is beneath you. People you know exist somewhere nearby. The darkness around you is interrupted at its edges. Light bleeding under a door, or through a curtain, or from whatever small device is carrying this voice to you. What this universe was, for roughly its first 200 million years, was nothing like that. For those 200 million years, a span that makes every ocean floor, every mountain range, every recorded human thought look like a single afternoon. There was no star anywhere in the observable universe. Not one. No galaxy. No fire of any kind. Only slowly expanding gas. Cooling from 4,000 degrees down to 60, drifting in a silence that was absolute, because silence requires no ears. And this universe in those years had none. Try to feel the size of that cooling. 4,000 degrees is hotter than the surface of molten iron. 60 degrees, on that same scale, is a cold deeper than any winter you have known, near the frozen background of empty space itself. The entire universe made that journey, from a furnace to a frozen dark, with no eye to watch it, and no warmth to lose, but its own, across more time than every living thing on Earth has existed, added together. Here is the fact that will slowly remake everything you think you understand about what you are. In the universe's first fractions of a second, matter and antimatter were produced in nearly perfect balance, and then they found each other and annihilated in a release of energy that human language cannot accurately hold. What survived was the remainder. One surplus particle for every billion pairs destroyed. That is what you are made of. That is what the stars are made of. That is what everything that has ever existed is made of. The whole observable universe, 100 billion galaxies, every atom resting in your hand, is the wreckage of an almost perfect cancellation. Rest on that for a moment. You do not have to do anything with it. You are the one part in a billion that was never undone. Most people assume the Big Bang flooded the universe with light. It did not. It took 380,000 years, longer than all of recorded human history multiplied by 50, for a single ray of light to travel freely through space. And when that light finally broke loose, the universe did not brighten. It went dark. And it stayed dark for another 150 million years, until gravity had slowly, patiently compressed the first clouds of pure hydrogen into the first stars that had ever burned anywhere. That oldest light is still arriving. It reaches us now, stretched and cooled by the long expansion of space to a temperature of just under 3 degrees above absolute cold. It is the last thing the universe said before the darkness closed over it. And it has been traveling toward you for nearly 14 billion years. You are hearing about the oldest thing there is, and there is nothing you need to do about it. Let the numbers pass through you. They were true long before you arrived, and they will be true long after, and for tonight you can simply rest inside them. By the end of tonight you will understand what existed in the universe's first fractions of a second, why almost all of it was destroyed. What a window of 17 minutes did to the chemistry of everything that would ever live. Why the darkness lasted as long as it did. And what finally, quietly, lit the first fire. Before we go further, if these slow journeys through the deep past are the kind of thing you want to fall asleep to, stay with gravity of sleep, and let this voice carry you into the next one. Get comfortable. Let the weight of your body settle into whatever is beneath you. Let your shoulders drop, and let the small tensions in your face and your hands go loose. There is nowhere you need to be. Nothing here you need to remember, nothing you need to hold on to. Follow this voice back to a time before any fire existed anywhere. Let's begin. Start with a smaller question than the enormous one we are chasing tonight. Not what came before the first stars, just this. How could anyone possibly know? You are lying in the dark. And it is easy to imagine that a time with no stars is simply a time no one can speak about, a blank page, a locked room. It would be reasonable to assume that the beginning is a story we can only guess at. It is not. We can date it. We can measure its temperature. We can say with real numbers how long the darkness lasted, and how cold it became. And the way we came to know these things is itself a slow story, told by patient people pointing careful instruments at the sky, each one reaching a little further back than the last. Begin with the darkness you already know. The darkness in your room tonight is a gentle, ordinary thing. It is broken everywhere by small mercies of light, a thread of it under the door, the soft gray of a window that never goes fully black, the faint glow of something charging in a corner. Your darkness has exceptions. The darkness we are traveling toward had none. No lamp, no window, no distant town, no single star anywhere in all of space to break it. It was a darkness without exceptions, and it stretched across the whole universe at once, and it lasted for a span of time so long that a human life disappears inside it like a single breath. And yet there is a wall we can walk right up to. The oldest light anyone has ever seen, the earliest thing any telescope or antenna has ever caught, comes from a single moment roughly 380,000 years after the beginning. That is the edge of sight. Before that moment, the universe was a fog, thick and glowing and impossible to see through. At that moment, the fog cleared, all at once, everywhere, and the light that was set free in the clearing has been flying toward us ever since. We catch it today. It falls on our instruments as a faint, even hum coming from every direction in the sky. It is the single most ancient thing you will ever be told about, and it is still arriving, right now while you lie there. Rest on the numbers for a moment, because they are worth holding gently. When that light was set free, the universe was still glowing at around 3,000 degrees. Then space itself kept expanding for 13.8 billion years, stretching that light thinner and cooler the whole way, until today it reaches us at just 2.725 degrees above absolute zero. It has been stretched by a factor of roughly 1100 on its long journey. What began as a furnace glow arrives as the coldest whisper, barely above the lowest temperature that can exist anywhere. You do not need to remember the figure. Let it pass through you. Just notice this. A fire from the dawn of everything has cooled, across billions of years, into something so faint that finding it at all counts among the quiet triumphs of the people who went looking. Now here is the hard edge of it. That wall, that moment 380,000 years in, is as far back as any eye or lens can go. Everything before it we do not see, we infer it. We reason our way toward it from the traces it left behind, the way you might reconstruct a fire you never watched from the pattern of the ash. And everything after it, in the long dark stretch we are really here to talk about, is nearly as hidden, because in that stretch there was no fire at all, no light was being made, there was nothing to see, and nothing making anything to see with. So the question becomes almost unbearable in its simplicity. If no light was made during the darkness, what signal could it possibly have left for us to find? There is one, just one. It comes not from stars, but from the gas itself, from plain hydrogen, the simplest atom there is, drifting cold and alone in the dark. Every so often, on its own quiet schedule, a single hydrogen atom makes the smallest possible change to itself, a tiny flip deep in its structure. And in doing so, it releases a whisper of radio energy at one exact wavelength, a wavelength of about 21 centimeters. One atom doing this is nothing. But the darkness was made of almost nothing else but this gas, ocean upon ocean of it, all of it whispering faintly at that same single note. That note is the only voice the darkness ever had. It is the one thread of signal that could carry, across all those billions of years, some word of what the universe was doing while it had no stars. But you cannot hear that whisper from where you are lying. Not from any rooftop, not from any desert, not from the highest and quietest mountain on Earth. Our own planet is wrapped in a thin electrified shell high in the atmosphere, and that shell reflects and scrambles exactly the kind of faint radio note we would need to catch. The Earth, in effect, is humming over the very frequency we are straining to hear. To listen properly, you have to leave. You have to go somewhere with no atmosphere and no human noise at all, and the place that keeps being named is the far side of the moon. The hemisphere permanently turned away from us. The quietest radio ground within reach. The instruments to do it are still only drawings and plans. Arrays with names that do not yet stand anywhere, waiting to be carried up and unfolded on that silent gray far shore. Still, people have tried to catch the whisper from here, and one attempt is worth sitting with. In the year 2018, a small, patient experiment reported that it might have heard something. Not a star, not a galaxy, a faint dip in the radio hum, a shadow at just the right frequency that seemed to come from about 180 million years after the beginning, from the era just before the first stars would have lit. If it was real, it was the closest anyone had ever come to touching the darkness directly, a single fingertip laid against the edge of the pre-stellar night. It made headlines. It made careful people hopeful. And then, just as carefully, it came apart. A second experiment went looking for the same shadow and did not find it. Where the first team heard a dip, the second heard only the ordinary difficulties of the machine itself. The small false signals that any antenna can fool itself with. As things stand, the detection is not confirmed. It is neither proven nor cleanly disproven. It hangs there, contested, a maybe. And there is something fitting, almost gentle in that. The darkest, least seen chapter of the whole story guards itself well. It does not give up its one whisper easily. If we cannot yet listen back to the darkness, there is another way people have gone at it, which is to build the fire again, here, on purpose, inside a machine. The conditions of the very early universe were not only dark and cold at the end. Near the very beginning, they were the opposite. Hotter than anything that exists in the cosmos now, and physicists can, for the smallest fraction of an instant, recreate a taste of that heat by smashing particles together at tremendous speed. As recently as the year 2025, researchers at Rice University measured the temperature of that recreated primordial state and found it blazing at somewhere between 2.01 trillion degrees and 3.25 trillion degrees, depending on how they chose to look at it. Trillion, not thousand, not million, a heat with 12 zeros standing behind it, held for an instant in a laboratory so that we could read the temperature of a universe that no longer exists anywhere but in these brief, deliberate sparks. And there is a third way still, which is simply to look as deep and as early as our best eyes can manage and see what the darkness eventually gave birth to. The newest great telescope in space has been catching galaxies so distant that their light left them only 280 to 300 million years after the beginning, some of the very first islands of stars to assemble once the long night finally ended. They are not the darkness itself. They are its children, the earliest lights we can actually resolve, and they are brighter and more finished than many of the careful predictions expected them to be, which is its own quiet puzzle for another night. For now it is enough to know the shape of what we are working with. A wall of oldest light we can see. A darkness behind it we can only reason toward. One faint whisper we are still building the ears to hear. And a scattering of dates and instruments, each reaching a little further into the black than the one before, which leaves the real work of tonight still ahead of us. Knowing that the darkness can be measured is not the same as knowing how it came to be, step by step, out of something far stranger than any darkness. So let the frontier settle for a while. Let the numbers loosen their grip. And let us go back now to the very first instance of all, and walk forward slowly through everything that had to happen, in its exact order, before there was ever any darkness to fall at all. But stay at that threshold for one more slow breath before you step across it. The road we are about to walk backward all the way to the first instant of all is not a road anyone was handed. Every number waiting on it, every temperature, every span of years, was pried loose slowly by ordinary people with machines they built by hand on days you could have marked on a calendar. And it is worth grounding yourself just for a little while in how recent all of this knowing really is. and in how each new instrument has reached a little further past the last one into the black. None of this is anything you need to keep. Let it move through you and be gone. But let it remind you, as you lie there, that the darkness we are chasing was measured by people who were, in their own quiet way, as small and as tired as you are tonight. Begin close to home, on Earth, in a laboratory. In the year 2025, physicists at Rice University did something that would have sounded like sorcery to anyone 100 years before them. They took the state of matter that filled the entire cosmos in its first millionth of a second, the quark-gluon plasma, that sea of unbound quarks and gluons far too hot to hold together into anything, and they made a little of it once more. Inside a collider, for the briefest imaginable flicker of time, they built again the fire of the newborn universe, and then they read its temperature. In the cooler region they measured 2.01 trillion degrees. In the hotter region, 3.25 trillion degrees. Rest on those numbers a moment. 2 trillion degrees is not a heat your body has any way to picture. It is not hot the way a flame is hot, or a furnace. It is a heat at which atoms themselves cannot survive, at which the pieces inside the pieces of matter come apart. And a handful of people on our small blue world made a spark of it on purpose, and measured it, in a year most of us still think of as barely yesterday. Then lift your gaze off the laboratory bench and out into the galaxy, because the next reach goes much farther. The first few minutes of the universe left a recipe behind. A fixed proportion of the lightest elements, roughly 3 parts hydrogen to 1 part helium by weight, with only the faintest trace of anything heavier. That recipe was set down when the whole cosmos was less than 20 minutes old, and the quietly astonishing thing is that we can still read it. We read it in the oldest, most barren stars we can find, the ones almost untouched by every later generation, nearly as old as the very ability to make a star. And we read it again in the light of distant quasars, in the faint shadows that ancient gas throws across their glow from billions of years away. 2 completely different ways of looking, one at nearby fossils, one at far-off light, and both of them hand back the same proportion the universe chose in its first quarter of an hour. The laboratory measured a heat we made ourselves. This measures a decision the cosmos made before a single star existed to witness it, and finds it still holding, unbroken, everywhere we check. Then reach farther still, with the newest eyes we have lifted above the atmosphere. Among the most distant things ever confirmed is a faint smudge of a galaxy that astronomers catalog, without romance, as jades, its light stretched by what we call a redshift of 13.2, which sets it a little more than 400 million years after the beginning of everything. Set aside, for tonight, the strange puzzle of how bright and how finished such early galaxies already look. Hold only the distance. We are seeing structures that formed while the universe was still in its infancy, ordinary starlight that left home when the cosmos had counted only a few 100 million of its nearly 14 billion years. And yet, even here, we have not reached the darkness. This is already the age of stars. The night we are hunting lies further back still, on the far side of even this. So go all the way to the edge of what any eye or machine can reach. Beyond the oldest star, beyond the most distant galaxy, there is a boundary, and it is made of light itself. It is the glow set free when the universe first turned clear, about 380,000 years after the beginning, and it has been traveling toward us without pause ever since, stretched and cooled by the swelling of space across 13.8 billion years. It departed as a fierce heat of a few thousand degrees. It arrives now, faint and even and cold, at 2.725 degrees above absolute zero, barely a breath above the coldest that anything can ever be. That is the oldest light there is. No telescope ever built, and perhaps none that ever will be, can see a single instant earlier, because before that moment the universe was a fog through which no light could pass. Everything older than that wall, every temperature and every epoch we will walk through tonight, we do not see with our eyes. We reason our way to it. We infer it from the way this cold, even glow is faintly dimpled by about 1 part in 100,000, with the shadow of the matter that lay behind it. And then there is the single reach that tries to enter the darkness that came after that light, the long age of no stars, and it is the most uncertain of them all. Buried in that night is one kind of signal that neutral hydrogen can send, a faint radio note released when an atom quietly flips the spin of its electron, stretched by all the intervening ages into a wavelength of around 21 centimeters. It is the only messenger that could ever carry word out of the dark. In the year 2018, an experiment called EDGES announced that it had heard something, a shallow dip in the radio hush at a distance, answering to roughly 180 million years after the beginning, right at the threshold where the first stars should have been catching fire. For a moment it seemed we had brushed the pre-stellar dark with a fingertip. But another instrument, a radio telescope named SARAS-3, went hunting for that very same dip and could not find it. The signal may have been the sky. It may have been the machine itself. And so, as things stand tonight, no one can honestly say we have heard the darkness, only that we reached for it, and that the question is still wide open, which is why the next instrument in this long history has not yet been built at all. The obstacle is our own planet. Earth wraps itself in a thin electrified veil, the ionosphere, and that veil turns back the very radio frequencies the darkness would speak in, the way a frosted pane turns back the shape of whatever stands behind it. To hear those first 100 million years cleanly, we would have to go where the Earth can no longer interrupt, to the far side of the moon, the one surface within our reach that is forever turned away from all our noise, and lay out a great array of antennas across that silent gray floor. There are designs for it already, carrying plain working names: Far View, Far Side, a listening post on another world, aimed squarely at the one era we have never observed. It does not exist. It is drawings and proposals and patient argument, and until it does, the longest night in the history of everything remains the least seen stretch of time there is, the one great chapter we are certain must be there and have never once looked upon. So understand clearly, before we begin, exactly what we are holding and what we are not, because this is the crushing truth beneath all the rest. Every single number that follows was won by people reaching, decade after decade, further into the black than any of them had reached before, and yet not one of those people, and not one of their machines, has ever laid eyes on the darkness itself, nor on the first star that finally broke it, nor been able to say, to nearer than tens of millions of years, on which night that first fire was lit. So we cannot look, but we can still travel. That is the quiet miracle underneath all of this. That even in the places no eye will ever reach, and no instrument will ever be built to reach, the mathematics still walks us inward, one careful step at a time, down the length of the earliest time, until at last even the mathematics runs out of ground to stand on. Tonight we are going to make that walk, not by seeing the beginning, because the beginning cannot be seen, but by reasoning our way back toward it patiently, the way you might feel your way along a wall in a dark room, until your fingers find the place where the wall simply ends. You do not have to carry any of this. Let that be understood between us now, before the numbers begin. Nothing that follows is yours to keep. Let it arrive, let it be enormous, and let it move on through you like a tide going out. Your only task tonight is to lie still and let the shape of it wash over you. Go back then. Back past the darkness we have been sitting inside. Back past the first star and the long night before it. Back past the first atom, the first particle, the first flicker of anything you could call a thing. Keep going until you arrive at the very first sliver of time the universe was ever allowed to have. Not the first year. Not the first day, not the first second. Something almost unimaginably smaller than a second. Picture a single second, the length of one slow breath in, one soft beat of your own heart. Now imagine cutting that second into 1,000 pieces, and one of those pieces into 1,000 more, and going on cutting and cutting, until you have divided that 1 second into a fraction so small that to write it down you would set a decimal point on the page, follow it with 42 zeros, and only then, at the very end, place a single one. That is how far into the first instant we are about to stand. Physicists have a name for that fraction of a moment. They call it the Planck time. And it matters because it is a wall. It is the earliest interval about which the laws of physics have anything at all to say. Before it, inside that first unthinkable sliver, our finest equations do not merely struggle. They stop. They return no answer. Everything humanity has ever learned about how the universe behaves, every law tested in every laboratory, every rule that has held across 13.8 billion years, arrives at that wall and can go no further. Not because we have not been clever enough yet, but because at that scale space and time themselves lose their ordinary meaning, and there is no longer any solid floor for the equations to rest upon. And the reason is heat. Unthinkable heat. In that first sliver of time, the universe was not warm, and it was not hot in any way your body carries a memory of. It stood at a temperature we call the Planck temperature, and its value is close to a number you would write as a 1 with 32 zeros trailing behind it. Say it slowly as a rough translation, and it comes out as something near 100 million trillion degrees. There is no use pretending those words mean anything to the body. They do not. There is no fire you have felt, no furnace, no lightning, no surface of any star that comes within an unimaginable distance of it. This is heat past the reach of comparison. And in that heat, everything that is now separate was one. Today the universe is governed by 4 great forces, 4 different sets of rules working side by side. There is gravity, the one you feel every second pressing you gently down into whatever you are lying on right now. There is electromagnetism, the force living inside light and inside every spark. There is the strong force that binds the hearts of atoms, and the weak force that lets them slowly change and decay. 4 forces, 4 separate rule books. But in that first sliver, in that heat, beyond comparison, they were not 4. They were one. A single unified law, a single behavior, with no distinction yet between the pull of gravity and the flash of light. The universe had not yet decided to become complicated. Rest on that for a moment, because it is one of the strangest facts a person can be told. Everything you are made of obeys those 4 forces in their separated form. The weight of your own arm, the warmth of your own skin, the light finding your closed eyes, the quiet chemistry keeping you breathing as you drift here in the dark. All of it depends on those forces being distinct, being 4. And there was a time, real time, the universe's own first moment, when that distinction did not exist. You could not have existed then. Not you, not your atoms, not the smaller pieces inside your atoms. Nothing you are was possible. There was only the one law, the one heat, and a universe smaller and hotter and simpler than anything that would ever come after. And here you might quietly wonder how anyone could possibly claim to know such a thing about a moment no one saw and no machine can reach. It is a fair thing to sit with as you lie there. The answer is that we have learned to build small pieces of that early fire and hold them still just long enough to measure them. In the year 2025, physicists at Rice University did exactly that. They took ordinary matter and drove it together with such violence that, for the briefest flicker, it came apart into a state the whole universe once wore. Not solid, not liquid, not gas, not even the familiar stuff of atoms, but something older. A sea of the smallest known pieces of matter, the quarks, set loose together with the gluons that normally bind them tight. All of it drifting free in a plasma the way it drifted free in the newborn cosmos. And they measured its temperature. What they found was a heat somewhere close to 2 trillion degrees in its cooler measurements, and, in its most extreme, better than 3 trillion degrees. Trillion, not thousand, not million. Trillion. And here is the humbling part. That searing, near unbelievable temperature, a heat we can barely make and can hold for only the smallest fraction of an instant in the most powerful machines we own, is not the beginning we have been describing. It is not even close. That plasma belongs to a much later, much cooler moment, when the universe had already fallen a long way down from the wall. The Planck heat stands so far above it that the gap between the two dwarfs, the gap between that plasma and the cool, dark room you are lying in. So let that reframe the size of what we are looking at. The hottest thing human beings have ever made is barely a whisper of the cold that came after the beginning. Not the beginning itself, not anything near it. Only a faint, late echo of a heat we cannot recreate and are not sure we ever could. And the beginning proper, the Planck wall, sits above even that, in a region our physics cannot describe and our machines cannot approach. Guarded on every side by that single fraction of a second with the 42 zeros folded inside it. You can let your shoulders drop here. None of this asks anything of you. It is only the oldest story there is, told softly in the dark, and you are allowed to let it blur at the edges. Let the trillions soften. Let the zeros lose their count. The universe did not remember its own first instant either, and it turned out all right. Because the universe did not stay at that wall. It could not. The very first thing it ever did, the only thing it could do, was fall. From that unthinkable heat it began, immediately, to cool. And everything that has ever happened since, every separation and every structure, every atom and every star, and the long darkness we came here to understand, is a consequence of that one long, unbroken fall away from the beginning. Cooling is the whole story. It is the single thread that runs from the Planck wall all the way to the room you are resting in tonight. The universe has been growing colder for 13.8 billion years, and it has never once stopped. And as it cooled, it grew complicated. This is the mechanism underneath everything we will follow tonight, and it is worth holding gently as we go. Heat keeps things simple and merged. Cold lets them separate and take on form. So as the temperature dropped from that first impossible height, the single unified law began, one stage at a time, to come apart into the four separate forces we know today. Not all at once, not in a single event, but in a sequence, like ice forming slowly across a still pond, each force settling out of the whole at its own moment, at its own temperature. Each separation quietly rewriting the rules of everything that followed. One by one, as the cold deepened, the forces are thought to have parted from the whole. And in one extraordinarily brief window very near the start, something happened that we are only beginning to reach the edge of. In a stretch of time so short it makes even that fraction with the 42 zeros look almost patient, the universe did something no calm word can quite hold. It did not drift. It did not spread the way a cloud slowly widens. It leapt. And that leap, that single violent instant of growth, is the next place we are going. It is where the faintest ripples, the ones that would one day become every galaxy, every star, and the great darkness between them were first written into the fabric of things. But before we follow it, let the ground you are on now settle under you. You have already come further back than any telescope can ever see. You are standing, in your mind, a single breath away from the beginning of time, inside a heat beyond all comparison, watching the first and simplest version of the universe begin its long fall toward everything that would ever be. Stay there a moment. Let it be quiet. Let it be warm. And when you are ready, we will take the next step down. So we step down, and the ground gives way beneath the small warm world you were standing in. The clock we are following has barely moved. We have not reached a millionth of a second. We have not reached a billionth. We are somewhere between a trillionth of a trillionth of a trillionth of a second and a breath just after it. A window so narrow that no word in any human language was ever built to name it. And in that window, the universe did the strangest thing it would ever do. It grew. Not the way bread grows, slowly, warmly, under a cloth. Not the way a child grows, over years you could count on your fingers. It grew by a factor of at least 100 trillion trillion. and it did it in less time than light would take to cross the width of a single atom. Hold that number a moment, because it will not hold still on its own. 100 trillion trillion. Take something far smaller than the smallest speck you could ever see, smaller than a single atom, smaller than the tiny parts inside that atom. Now imagine it swelling until it is wider than everything a telescope can reach tonight. That is roughly the leap. Not a gentle widening. A violent, silent, unimaginable stretch. And then, just as suddenly, it was finished. The whole event began and ended so fast that if you tried to lay it against one single tick of a clock, you would have to divide that tick into more pieces than there are grains of sand on every shore on Earth. And here is the quiet heart of it, the reason this one instant matters more than almost any other in the entire story. Before the stretch, the infant universe was not perfectly smooth. It could not be. At that scale, the world trembles on its own, flickering with faint quantum ripples, little unevennesses that rise and fall too small and too quickly to ever amount to anything. Under ordinary conditions, they would have stayed nothing, meant nothing, mattered to no one. But the stretch caught them. It seized those microscopic tremors and pulled them wide, froze them into the fabric of space at an enormous scale, and made them permanent. Every ripple that would ever matter was written in that single sliver of time, and they were faint, almost beyond belief. When, much later in this story, that early unevenness can finally be read directly, printed across the oldest light in the sky, the warmest patches differ from the coolest by only about 1 part in 100,000. That is the whole difference between a universe full of galaxies and a universe of empty dark. 1 part in 100,000. A thinness of frost you would never notice on a cold window, and yet everything grew from exactly that. Think of what those ripples became. Where the stretched fabric was very slightly denser, gravity would one day gather gas, and gas would one day gather into the first structures, and inside those structures, far in the future, the first light would kindle. And where the fabric was very slightly thinner, almost nothing would gather at all. Those thin places became the great voids, the vast dark rooms between the galaxies, the emptiness that fills most of the universe you live in now. So the light and the darkness were decided together, in the same breath, from the same tiny trembling. The seeds of every galaxy, every star, and the immense darkness between them were all sown in that instant, long before there was a single atom to feel it. And this is the part to let settle against your own skin. The particular arrangement of matter that became your galaxy, that became the cloud, that became the star, that became the dust, that became this planet, and in the long, slow end of it became you, traces back to one of those frozen ripples. Not a poem, a physical inheritance. The faint unevenness that gathered the gas that built everything you have ever touched was set in place in a fraction of a second, so brief it has no felt duration at all. You are, in the most literal way, the grown-out echo of a wrinkle in almost nothing. The weight of your own body against the bed right now is resting on a decision the universe made before it was even a millionth of a second old. And speaking of weight, of that very feeling of heaviness pressing you gently down into where you lie, there is one more thing that had to happen before matter could carry any weight at all. Follow the clock forward again past the great stretch, and let it run on to about 20 trillionths of a second. Still unthinkably early, still hotter than anything that will ever exist again, more than 1,000 trillion degrees. At that moment, the forces that rule the world were still tangled together, and two of them, the force that carries light and the force that governs a certain kind of radioactive decay, finally let go of one another and became separate powers, the way they have stayed separate ever since. And in that same unfastening, something switched on that had never been on before. A field woke through all of space, and as the particles moved through it, they began for the very first time to drag. They began to resist being pushed. They began, in the only sense the word has ever truly meant, to have mass. Before this, everything raced at the full speed of light, weightless, unslowable, unable to rest. After it, matter could be heavy. Matter could be still. Matter could, one distant day, gather and settle and lie down. The very property that lets your body sink into the mattress and stay there, the plain thing we simply call weight, flickered into being about 20 trillionths of a second into the life of everything that is. So rest there a moment longer, held by a heaviness that is itself only a few trillionths of a second old. You do not need to keep any of these numbers. Let them fall through you like sand through open fingers. There will be no test in the morning, nothing to carry, nothing to hold. What matters is only the shape of it, the quiet sense of lying inside a universe that has just been stretched and seeded and given its first weight, all before a single second has passed. But the story does not soften from here. It sharpens. Because in the very next moment, still inside that first second, the young cosmos will fill with matter and with its exact mirror twin, and the two will turn upon each other in a reckoning so complete that almost nothing at all should have been left behind. What remained, and why anything remained, is where we are going now. So stay here with me, in the first flicker of a second, because what fills the universe now is not calm, and it is not empty. It is the hottest, densest, most crowded instant there will ever be. Every particle that can exist is here, pressed shoulder to shoulder in a space still unimaginably small, and none of it is yet arranged into anything you would know by name. There are no atoms. There are no protons. There is not yet a single grain of ordinary matter of the kind your body is built from. There is only a sea. Physicists have a name for this sea, and the name is the quark-gluon plasma, and for a long stretch of that first second, the plasma is all there is. Let the word settle. From about 1/1,000,000th of a second after the beginning, the universe is a fluid of the smallest things there are. Quarks, the pieces that will one day hide inside every proton and neutron. And gluons, the force that will one day glue them shut. But here now, they are not glued to anything. They are free, streaming through one another, too hot to hold together, too fast to be caught. The temperature of this sea is close to 2 trillion degrees. Not 2,000. Not 2,000,000, 2 trillion. Say the number slowly, and it stops meaning heat at all, because there is nothing in your life, nothing on your world, nothing at the surface of any star you can name that comes within a breath of it. The core of our own sun burns at roughly 15 million degrees, and that figure is already beyond anything a body could picture. This sea is more than 100,000 times hotter than the center of the sun. And here is the quiet, strange thing about it. We have touched it. Not the whole of it, not the universe, but the substance itself, this same quark-gluon plasma, has been made again by human hands, in machines buried underground, in rings of tunnel where atoms are driven almost to the speed of light and smashed into one another. Physicists have recreated tiny fleeting droplets of that primordial sea, the very same free quarks and gluons that filled all of space in the first 1,000,000th of a second. And they have measured how hot those droplets are. In the year 2025, researchers at Rice University reported their reading, and they found it. Around 2 trillion degrees in one region, and closer to 3¼ trillion degrees in a hotter part. Numbers taken not from a story about the early universe, but from a droplet of the early universe, remade for a fraction of a second on the floor of a laboratory. The oldest state of matter there is, held once more, for an instant, and read like a thermometer. You do not have to keep those numbers either. Let 2 trillion degrees drift past you the way the earlier ones did. You are lying still, wrapped and warm, and none of this heat can reach you across the 13 billion years between then and this bed. That is the gift of the distance. It lets you look at the fire without ever feeling it. Now the plasma cannot last. Nothing this hot can last, because the universe is still doing the one thing it has done since the beginning. It is expanding, and as it expands it cools. And as it cools, the sea begins, at last, to freeze. Not into ice, into matter. At about 20 millionths of a second after the beginning, the universe crosses a threshold, and the free quarks that had streamed apart for so long are suddenly no longer free. The gluons catch them. 3 quarks here, 3 quarks there, snap together into tight little bundles, and each bundle is a proton, or a neutron. This is the moment ordinary matter is born. Not the atoms yet, not the elements, but the heavy hearts of them, the protons and neutrons that everything solid will one day be built from. After this crossing, no quark will ever roam alone again. They are locked away 3 to a room for the rest of time. Consider what has just happened, quietly, in the dark, in less time than it takes a nerve to fire. The building blocks of your own hands were assembled here. The protons in the calcium of your bones, the protons in the iron of your blood, every single one of them was sealed shut in this instant. 20 millionths of a second into everything, and not one has come unbound since. You are, in the most literal way, older than you can feel. The parts of you were finished before the universe was 1,000th of a second old. But I have told you only half of it, because when the protons and neutrons formed, they did not form alone. For every particle of matter that appeared, there appeared, at the very same instant, its exact and opposite twin. We call these twins antimatter. Every proton had an antiproton, identical in every way but mirrored, carrying the opposite charge. Every particle of matter had a shadow made to cancel it, and matter and antimatter cannot share a world. When one meets the other, they do not fight, they do not scatter. They simply end, both of them at once, vanishing into a flash of pure light. This was not a rare event or a strange exception. In the young universe, it was happening everywhere, endlessly, matter and antimatter finding each other and annihilating, turning themselves back into radiation as fast as they had formed. So picture the reckoning honestly. A universe filled edge to edge with matter and with the perfect enemy of matter, and the two of them erasing one another in a storm of light that has no equal before or since. By every fair accounting, this should have been the end of the story. If the two sides had been evenly matched, if for every particle there had stood exactly one antiparticle, then the annihilation would have been total. Everything would have found its opposite. Everything would have canceled. The universe would have burned through all of its matter in that first storm, and been left with nothing but light, an endless, expanding, cooling glow of radiation, and not a single speck of solid stuff anywhere within it. No protons left over, no atoms ever, no stars, no worlds, no bodies, no one lying in the dark to wonder about any of it. A cosmos of pure light, and no witnesses. That is not what happened. And the reason it is not what happened is one of the smallest and most consequential imbalances in all of science. The two sides were not evenly matched. They were almost evenly matched, which is a very different thing. For every 1 billion particles of antimatter, there were 1 billion and 1 particles of matter. 1 extra. 1 in a billion. Not a flood of surplus, not a comfortable margin, but a single grain of difference for every billion perfect pairs. And so when the great annihilation came, and the pairs found each other and vanished into light, the counting did not come out even. A billion met a billion and canceled to nothing, and the one that was left over had no partner to end it. That one remained. Let that arithmetic settle, because it is the arithmetic you are made of. Everything solid in the universe tonight, every star and every galaxy, every planet, every stone, every drop of water, every cell of every living thing that has ever lived, all of it is the remainder. All of it is that 1 particle in a billion that happened to have no twin. The other billion are gone, turned to light in the first heartbeat of time, and their light is still around us, filling the whole sky, which is a story we will come to. But the matter, the you, the this, the entire furniture of existence, is only what was left after the near total cancellation of almost everything. The universe kept 1 part in a billion, and out of that thin remainder it built worlds. There is a name for the process that tilted the scale, that laid down that 1 in a billion excess in the first place, and the name is baryogenesis, the making of the matter that stayed. And here honesty asks for a soft admission. We do not fully understand it. We can measure the leftover with great precision, we can count the ratio, we can read the fingerprint of that imbalance written across the sky, but the exact mechanism that made matter win by that razor-thin margin, instead of losing or instead of tying into nothing, remains one of the genuine open questions. We know that it happened, because we are here. We do not entirely know how. The universe leaned, by the smallest amount it possibly could, in favor of something rather than nothing, and it has not yet told us its method. So the universe at the end of its first storm has fallen into a very particular kind of quiet. The pairs are gone, the light they became is everywhere, and scattered thinly through all of it, 1 part in a billion, are the survivors, the protons and neutrons that were never cancelled, drifting now through a cooling ocean of radiation with nowhere yet to go and nothing yet to join. They are the entire future inventory of everything. Every atom that will ever exist is already present, here, in this thin remainder, waiting in the dark. But they are still alone, still bare, still nothing more than separate particles adrift. What becomes of them next, in the few short minutes that follow, will fix the chemical shape of the whole universe for all of time. And that is where we turn now. Consider first what leaves. Barely a single second has passed since the beginning, and already the universe is shedding its first ghost. The temperature has dropped to around 10 billion degrees. Still unthinkable heat, hotter than the core of any star that will ever burn, and yet for the first time cool enough for one kind of particle to simply let go. The neutrinos decouple. Until this instant they had been caught in the churn with everything else, colliding, scattering, bound into the general fever of the young cosmos. Now the crowd has thinned just enough that they stop interacting. They slip loose from the matter around them, and they begin to fly. And here is the quiet, staggering part. They never stopped. Those very neutrinos, released 1 second into time, are still in flight tonight. They are passing through you as you lie there. Billions of them cross every fingernail width of space every second, and they move through your body, through your bed, through the whole of the earth beneath you, as though none of it were there. They carry the imprint of a universe 1 second old, and they have been traveling for nearly 14 billion years to reach the dark of your room. You will never feel them. You do not need to. There is nothing here to hold on to, nothing to remember, nothing being asked of you. Let the number pass through you the way those ancient particles are already passing through you, without weight, without effort, and let your shoulders settle a little further into the dark. The universe keeps falling. The heat bleeds away as space stretches, and the temperature slides from 10 billion degrees down toward a single billion. And in that cooling, a very narrow window begins to open. It is not a long window. It will last only minutes, but everything you are made of, every atom in your hand, in your breath, in the water you drank today, is about to be decided inside it. The bare protons and the bare neutrons, drifting since the great annihilation with nothing yet to join, are finally moving slowly enough that when they touch, they can stick. Fusion becomes possible. The universe is about to write its recipe. We call this stretch Big Bang nucleosynthesis, and it runs from roughly 10 seconds after the beginning to somewhere near 1,000 seconds. About 17 minutes, less time than it takes to soften into sleep, less time than a warm bath. In that brief span, protons and neutrons begin to lock together into the first true atomic nuclei the universe has ever held. Not atoms yet, not whole, not neutral. Just the dense cores, the seeds. A proton and a neutron bind into heavy hydrogen. Those join and gather until they build helium. And the window is racing shut even as it works, because the universe is expanding and cooling with every heartbeat, pulling the particles apart, dropping the temperature below the threshold where fusion can continue at all. When the 17 minutes end, the accounting is finished, and it is finished for good. Roughly 3/4 of all the ordinary matter in existence is now hydrogen. The simplest thing there is, a single lonely proton. Roughly 1/4 is helium. about 75% and about 25% by weight, hydrogen and helium, settled and sealed. That is the entire opening inventory of the cosmos. Think of what that means as you lie here. Before there was a single star, before there was a grain of dust or a drop of water or a living cell, the universe had already chosen, almost entirely, what it would be built from. And it chose in less time than you have been listening to this voice. There were traces of other things too, made in that same rush and never much added to. A thin dusting of deuterium, that heavy hydrogen, most of which survived by luck. A whisper of helium-3, and the faintest touch of lithium, the third element, present in amounts so small they are still difficult to measure. And then nothing more. No carbon, no oxygen, no iron, no gold, no calcium for a bone, no nitrogen for a breath. The window closed before the universe could build anything heavier. Everything else you are made of does not exist yet, and will not exist for a very long time. It is waiting inside stars that have not been born. Sit for a moment with how narrow the escape was. Had the universe cooled a little more slowly, had that window stayed open even a little longer, more of the hydrogen would have burned onward into helium and beyond, and the cosmos might have emerged nearly out of the one fuel that stars would later need most. Had it expanded a little faster, the particles would have been torn apart before they could bind at all, and there might have been almost no helium, almost no heavier seeds, almost nothing to work with. The recipe balances on the rate at which everything was flying apart. Change that rate by a small fraction, and the shelves of the universe are stocked differently, and the stars that follow burn differently, if they burn at all, and the chemistry that leads eventually across billions of years to a body lying in a dark room, listening, may never assemble at all. This is the calm, unsettling truth beneath the whole night sky. You are not made of anything new. The hydrogen in every glass of water you have ever drunk was forged in those first 17 minutes and has never been remade. When you breathe out, some of what leaves you traces back, atom by atom, to a recipe locked in when the universe was younger than a bath grows cold. Nothing since has changed those numbers. Stars have lived and died. Galaxies have turned. 14 billion years have passed. And still 3 parts hydrogen to 1 part helium, the same proportion the cosmos wrote for itself while it was barely minutes old, holding steady across all of time. And we know this is not a story we told ourselves. We can read that same ratio today, written into the oldest and faintest things we can find. In the most ancient stars, the ones so poor in heavy elements that they must have formed before much enriching had happened, we measure very nearly the helium fraction the theory demands. When we look at the light of distant quasars, blazing from the far edge of the universe, and we watch that light pass through clouds of primordial gas on its long way to us, the gas leaves its fingerprints in the beam, and those fingerprints too match. 3 separate windows into the deep past, the theory, the old stars, the ancient gas, and they agree. The recipe was real. It was cooked once, in a hurry, and never again. So the universe now has its ingredients, but only its ingredients. A cooling fog of hydrogen and helium, salted with the barest traces of the lighter things, and threaded through with the survivors from the annihilation, and flooded still with light, and with the neutrinos that will outlast everything. It is fixed. It is finished. The chemistry is decided, permanently, while the universe is still only minutes old, and it will carry that decision forward untouched through everything that follows. And yet, for all that certainty, the young cosmos remains blind to itself. It is dense, it is hot, it is opaque, a fire so thick that light cannot cross it. Nothing can be seen, nothing can shine out. The recipe is written, but the universe cannot yet read it, cannot yet let a single ray travel free. That release, the moment the fog finally thins and the first light is allowed to leave, is still a very long way off, measured now not in seconds, but in something far stranger, That stranger thing is time. Not the racing time of those first minutes, where whole eras opened and closed inside a fraction of a heartbeat, but time slowed almost past recognition. Stretched thin, spread out across spans so long that nothing much seems to happen at all. Up to now, the universe has lived its entire history in the space of about 20 minutes. From here on, it will measure itself in tens of thousands of years, and then in hundreds of thousands, and you will feel the tempo change. Let it change in you as well. There is nothing here you need to hold. You can let the seconds go now, and let the centuries go with them. For a long while, the cosmos simply cools, and thins and waits. Then, somewhere near 47,000 years in, a quiet handover takes place. It is not a flash. It is not an event you could have watched. It is a shift in who is in charge. Until this moment, the universe has been ruled by its own light, by radiation, by the sheer pressure of all those photons pushing outward, keeping everything smooth, refusing to let anything gather. The light held the room. But as space keeps expanding, that radiation loses its grip. It dilutes, it softens, and matter, patient and heavy, finally takes the lead. Not the glare of light, but the quiet weight of things. And the moment weight takes over, gravity is free to begin its slow and patient work. Those faint unevennesses seeded long ago, the quantum whispers that inflation stretched into ripples across the whole sky, have been waiting for exactly this. Radiation would not let them grow. Gravity will. And so, invisibly, without a sound anyone could name, the very slightly denser regions begin to pull. Nothing collapses yet. Nothing lights up. But the first faint architecture of everything that will ever exist, every galaxy, every cluster, every long thread in the great web to come, begins right here, as the smallest tilting of a balance, in the dark. And through all of it, the universe is ringing. This is one of the stranger things to sit with, so let it come to you softly. The early cosmos was not silent. It was a fluid, dense and hot. And through that fluid, pressure waves rolled, the way sound rolls through air. They moved fast, faster than you could picture, at more than half the speed of light, roughly 57% of it, sweeping through the plasma as vast, slow tones. Compressions and thinnings, a chord held across the entire width of the sky. You could not have heard it with an ear. But it was there, a music written in matter and in light, so faint in all its variations, only about 1 part in 100,000, that it barely disturbed the smoothness at all. The universe hummed to itself in the dark, and it had been humming since the very beginning. And then it went quiet. Around 380,000 years after the beginning, the temperature falls to somewhere near 3,000 to 4,000 degrees. That is still hot. It is roughly the heat of a dying ember, the dull red of a coal near the end of a long fire, the surface glow of the very coolest stars. But for the universe, it is a threshold. It is cool enough, at last, for something that has been impossible for the whole of its life. Consider that span for a moment before we cross it. 380,000 years. Our own kind, modern humans, have walked this planet for something closer to 300,000. So the universe spent longer waiting for this single change than our entire species has so far existed. All of us. Every life ever lived. Every language, every name, every song anyone has ever sung would fit inside that wait with room left over. And you are lying here in the quiet, letting it pass through you in a single breath. For all of that time, the universe has been opaque. It was filled with free electrons, loose and unbound, and free electrons scatter light endlessly, throwing every photon sideways before it can travel any real distance at all. Light existed, in enormous quantity, more light than anything. But it could go nowhere. It was trapped and bounced and imprisoned in its own fog. The universe was brighter than anything you can imagine, and blind at the very same time. Then, at 3,000 degrees, the electrons slow just enough to be caught. Protons reach out and hold them. For the first time, whole neutral atoms form, hydrogen and helium, quiet and stable, and the free electrons disappear out of the way, folded safely into atoms, no longer loose to scatter anything. Cosmologists call this recombination, though nothing is truly recombining that was ever joined before. And in an instant, on the scale of the cosmos, the fog lifts. The universe becomes clear. Light is set free to cross space in straight lines for the first time in its existence. Those photons, released in that one moment of clearing, are still traveling now. They have been crossing space for 13.8 billion years, and they are still arriving. Stretched by the expansion of everything, cooled from that ember glow of 3,000 degrees down by a factor of about 1,100, they reach you now as a whisper just under 3 degrees above absolute zero, at 2.725 degrees. That is the oldest light there is. The furthest back any eye, any instrument, anything at all can ever hope to see. A wall of soft light, with nothing visible behind it. And here is where almost everyone gets it wrong. We are taught to imagine this moment as a dawn. The fog lifts, the light breaks free, the universe turns clear, and it sounds, in the way the story is usually told, like a beginning, like a switching on, like the instant the cosmos opened its eyes and the great age of light began. It is not that. It is very nearly the opposite of that. Not the dawn, but the dusk. Not the first morning, but the last of the light before a very long night. Because that light which was finally set free was also leaving. It streamed outward and away, redshifting, reddening, draining out of the visible and down toward the cold, growing fainter with every year the universe grew wider. The clearing did not fill the sky with brightness. It emptied it. The fog that lifted did not reveal a lit and waiting cosmos, warm and ready. It revealed, instead, how little there was to see. So look at what actually remains, once the fog is gone. Hydrogen, helium, a bare trace of lithium, cold, dark, neutral gas, spread thin through an expanding dark, and the fading afterglow of that one released light, reddening steadily out of sight as the years go by. There are no stars, not a single one. There are no galaxies. There is no fire anywhere in all of it. The universe has just become perfectly transparent, clear from end to end, able at long last to carry light across its whole enormous width, and there is almost nothing lit to carry. Sit with that quietly. It is not a frightening thing, not from where you are, warm and still and safe. It is only very large and very empty, and it asks nothing of you. Let your shoulders soften as you hold it. Let your breathing slow to the tempo of a universe that has all the time there is. We call this the release of light. It might be truer and stranger to call it the beginning of the dark. Recombination did not turn the universe on. It is the moment the universe could finally go out. The music has stopped. The ringing plasma has cooled into silence, and neutral gas does not ring. The last glow of that first fire dims and reddens and slips below the edge of anything an eye could catch. And behind it there is no new light rising to take its place. None at all. Not for a span of time so long that it makes the whole rushed story so far, all those forces splitting, all that matter forming, all that furious early heat, look sudden by comparison, over almost before it started. Because this is the turn the title has been circling from the very first word. The question was never really what came before the stars, in the sense of ingredients of physics, of the recipe cooked in those first minutes. We have that already. The deeper answer, the one that recontextualizes everything you have followed tonight, is a question of endurance, of duration, of how long a cosmos can go on existing with everything in place, and still have nothing to show for it. The stage is fully built. The chemistry is fixed. The light is released. And then the universe steps into the longest, deepest, most patient darkness it will ever know, and it stays there, and it stays there, for an amount of time that dwarfs everything that made it. That darkness is not empty of consequence. Something is happening inside it, slowly, invisibly, in the cold. But nothing shines. And to understand how long that night truly lasts, and what is quietly assembling within it while no light falls anywhere, we have to stop counting in thousands of years and learn to count in millions. Millions. Let the word settle, because it marks the place where the scale of this story quietly changes shape. Everything you have followed so far happened in a hurry. The forces came apart in slivers of a second. The first nuclei were forged in something close to 17 minutes. The light tore free of the fog in a few 100,000 years. You have been living, up to now, inside a cosmos that did everything fast, that could not seem to hold still. And here, at last, the hurry stops. Here the universe does the one thing it has never done. It waits. It does nothing that shines for longer than it has yet existed, and it does that nothing without hurry, the way a room stays dark after you have already turned toward sleep. Now hold up the thing that almost everyone gets wrong, because you are probably carrying it too. When you hear the words "the beginning of the universe," you see brightness. You see a flash, a blaze, a great outward burst of fire. The very name we gave it, the Big Bang, paints a blinding flare thrown across the black. It may be the most misleading name in all of science. There was no bang you could have heard, because there was no air and no ear. And for by far the longest early stretch of the cosmos, there was no light you could have seen at all. The truth runs almost exactly backward from the picture in your head. The birth of everything was not a brilliant explosion staged against a dark theater, not a burst, not a beacon. The birth of everything became, for an unimaginably long while, the darkness itself, arriving, thickening, and staying put. And this darkness is not a short intermission between the fireworks and the first stars. It is not a pause between acts. It is, by a wide margin, the longest single chapter the young universe had yet lived. Everything that came before the fog lifted, every force and flash and fusion you have followed tonight, all of it fit inside roughly 380,000 years. The darkness that followed lasted something like 150 million years, and by some accounts closer to 200 million. Set those beside each other and the arithmetic becomes almost unkind. The night was not a little longer than everything before it. It was hundreds of times longer. If all of creation up to the clearing were a single day, the darkness that followed would run for the better part of a year, an unbroken year of nothing lighting up anywhere. Feel the cold arriving inside that year. At the moment the fog lifted, the whole sky still glowed, a dull uniform red, the color of the inside of an oven cooling down, near 4,000 degrees on the Kelvin scale, warm enough to shine faintly everywhere at once. But the universe kept expanding, and expansion stretches light, and stretched, light reddens and dims. So that glow slid slowly out of the range your eyes could catch. It slid from red into the infrared, into warmth you could only feel and never see, and then further still, down toward the faint microwave hush it has become today. There was a long twilight when the entire sky was a single fading ember, and then even the ember went out, and the gas itself kept cooling, from thousands of degrees down towards 60, above absolute zero, colder and quieter with every passing million years. You do not need to hold any of these numbers. Let them drift down through you like the temperature itself, cooling, settling, softening. Let your shoulders go with them. There is nothing here to keep, nothing here to solve. There is only a very old darkness, and you, lying in a smaller darkness of your own, and the slow permission to let both of them be. Because here is the turn, the quiet reversal the whole night has been walking toward. That darkness is not empty. It only looks empty from outside, the way a still field looks empty at night. Not empty, but working. Not idle, but building. While no light fell anywhere across the observable universe, gravity had already begun its patient, invisible labor, and the thing it was assembling could not be seen by any eye or any instrument, then or now, because it gives off no light of its own. Around 75 million years in the deepest part of that night, the unseen matter that outweighs everything ordinary began to gather itself into clumps. Not the hydrogen you could one day touch, not the helium, something quieter than either, pulling inward on itself in the cold. These first gathering places were not grand. They were faint knots of dark matter, each holding something between 100,000 and 1,000,000 times the mass of the Sun, forming while the cosmos was still perhaps 100 to 175 million years old. But each knot dug a well in the shape of space, a low place for things to roll toward. And the ordinary gas, the hydrogen and helium locked in during those first 17 minutes, began to slide down into those wells and pool there in the dark. As it fell, some of it paired off into molecules, hydrogen atoms finding hydrogen atoms. And those molecules did something the bare atoms could not. When they collided, they shed a little heat as faint infrared light, and by shedding heat they let the gas grow colder and denser and slower, sinking further into the well over millions upon millions of years. Sit with what that means, softly, before you drift. In the very middle of the longest darkness the universe would ever know, with no star anywhere and no promise that one was coming, the machinery for the first fire was already being wound. Not announced, not visible, not fast, just gas, cooling into invisible cradles, 1 degree at a time, 1,000,000 years after another. The night was not the end of the story. It was the pregnancy of it. The darkness was not an absence of what would come next. It was the slow, cold gathering of everything the next thing would need. And that is the fragile hope buried in the dread, and the two of them turn out to be the same fact seen from opposite sides. The dread is the sheer length of the waiting, 150 million years without a single point of light, the universe fully assembled and utterly unlit, as if a house were built and furnished and then left standing empty through winter after winter. But the hope is that the emptiness was never truly empty. Something was falling inward the whole time. Something was cooling toward a threshold it had not yet crossed. The stage was not just built and abandoned. It was being loaded, quietly in the dark, with the one thing that had not yet happened. So the question that opened tonight was never only what the universe was made of before the first stars. You know the ingredients now. Hydrogen, helium, a whisper of lithium, darkness. The deeper question, the one still ahead of us, is how close that darkness came to lasting forever, and what exactly tipped it over, and how a cosmos of nothing but cold gas and unseen mass finally, after all that patience, learned to burn. To follow that, we have to go down into the dark ourselves, into the coldest and least understood stretch of all cosmic history, and look closely at the invisible thing gathering in the deep, and at the single faint signal that may be the only word the darkness ever sent us. So come down into it now, gently, the way you are already sinking into the dark of your own room. There is no floor to land on. There was no floor then, only gas, spread thinner than any breath, colder than anything your body has ever touched, and above it and below it and running straight through it, no light at all. Not dim light, not distant light, none. We have a name for this stretch of time, and it is not a poet's flourish. It is a plain description. The cosmic dark ages. For a span that lasted somewhere near 150 million years, the universe held not a single star, not a candle, not a spark, not one point of visible light anywhere across the whole of everything that was. Sit with the size of that, and then let it slip away, because you do not have to keep it. 150 million years. If you tried to live through it 1 year at a time, one slow heartbeat after another, you would wear out the whole of yourself, and be born and worn out again, more than 2 million times over before the darkness so much as shifted. All the human lives that have ever been lived, laid end to end, would still fall short of filling that one long night. And nothing in it changed. No sunrise, no morning, nothing at all to mark the passing of any of it. The night had a beginning, and the beginning was almost tender. Around 380,000 years after everything started, the fog that had filled the young universe finally lifted. The heat had fallen far enough for the first whole atoms to hold together, and the thick haze of loose, charged particles thinned and cleared, and light, for the first time, was set free to travel in a straight line. In that moment, the whole of space glowed a dull and even red, the color of an ember on its way out, everywhere at once. That glow was the last of the old fire. And then, slowly, it went. It went, because space would not stop growing. As the universe expanded, that even red glow was stretched along with it, its warmth spreading thinner, its color sliding down and away below anything an eye could hold. The red deepened into an infrared no eye can catch, and then slid further still into the long, cold, patient wavelengths we now call microwaves. The light was never snuffed out. It simply stepped out of the visible world and kept going. And when the last of that glow crossed below the edge of red, the lights of the universe were, for every purpose that matters, off. At the start of that long dark, the gas was almost warm by the standards of empty space. A few thousand degrees. Around 4,000 degrees above the coldest cold there is, which is close to the heat you would find at the surface of a small and modest star, though of course there were no stars anywhere to measure it against. And then, over those 150 million years, the gas did the only thing left for it to do. It cooled, slowly, without end, from 4,000 degrees down and further down, until the whole of the universe drifted at somewhere near 60 degrees above absolute zero. Colder than any winter you have shivered through. Colder than the night side of any world. A cold so nearly total that it sits closer to the true floor of temperature, the place where all motion finally stops, than to anything your skin has ever known. And in all that cold, in all that lightlessness, what was actually there? You have been carrying the answer with you the whole way. 2 gases, and almost nothing else. Something near 3 parts in every 4 of it was hydrogen, the simplest thing that can be called matter. Nearly all the rest was helium. And threaded through it, a trace of lithium so faint you could sift a whole swimming pool of that first gas and scarcely turn up a single atom. That was the entire stock of creation. 2 plain gases and a rumor of a third, spread impossibly thin, and around them, in every direction, the dark. That is the honest and unhurried answer to the question this whole night began with. Before there was any star, the universe was cold hydrogen, a 1/4 part helium, a whisper of lithium, and a darkness that outlasted almost anything you could put a name to. But here is what the word darkness quietly hides from you. It sounds like nothing was happening. It sounds like a held breath, a pause, a long empty waiting room set between the flash of the beginning and the fire still far ahead. That is the picture most people carry, on the rare nights they carry any picture of it at all. An empty universe, simply waiting for something better. It is not right. The dark was not idle. The dark was at work the entire time. Because gravity has never needed light. Gravity does not ask whether anything can be seen. It does not wait for a witness. And in that cold and lightless gas, and in something stranger still that was woven all the way through it, gravity had already begun its slow and patient pull, long before there was anything to shine on the result. That something stranger is the deeper part of this story, and it is where the darkness turns from a simple absence into something that should unsettle you, softly, the way the best strange things do. Because the ordinary gas, the hydrogen and the helium you can at least picture in your mind, was never the heaviest thing in the room. Running through all of it, outweighing it several times over, was a kind of matter that gives off no light, that swallows no light, that bends nothing you could ever look at, and that no one to this day has ever seen directly. We call it dark matter, and that name is only a polite word for our own ignorance. It means matter whose weight we can feel, and whose face we have never found. And through the whole of the Dark Ages, this unseen thing was the quiet architect of everything that was still to come. Somewhere near 75 million years into the long night, this invisible matter began, ever so gradually, to gather. Not with any haste. Nothing here moved with haste. But the faint unevenness left behind from the very first instant of the universe, those tiny ripples that were stretched to enormous size in the first thin sliver of a second, meant that some regions of space held a breath more mass than the regions beside them. And where there was a little more, gravity pulled a little harder. And where it pulled a little harder, a little more arrived. And so, across millions of years, in complete and unbroken darkness, the unseen matter slowly drew itself inward, into clumps. These clumps carry a name that badly undersells them: minihalos. Each one, once it had drawn in enough of itself, held something on the order of 100,000 to 1,000,000 times the mass of our sun. And yet not one grain of it could be seen. They were wells. Not wells dug down into any ground, but low places pressed into the very shape of space, dips and hollows toward which anything nearby would begin, slowly, to fall. And the gas did fall. The cold hydrogen and the thin helium, drifting through the dark with nowhere in particular to be, felt those unseen hollows open beneath them, and started the long slide inward. Not swiftly. You have to keep releasing that idea of swiftly. This was a settling that took millions of years on its own, gas draining down toward the center of a thing it could never see, pooling there, thickening there, growing very faintly warmer as it pressed in on itself, and none of this asks a single thing of you. You do not have to hold these numbers. You do not have to keep the order of it neat, or remember which came first, the cold or the falling or the gathering mass. Let the years pour past you. Let your jaw loosen. Let your shoulders come down away from your ears. Let your breath go slower than it was a moment ago. The universe took